In the last session, we have discussed about the problems, how to calculate power, how to calculate the strength, how to calculate the dynamic load, wear load, and efficiency of the work made, and how to calculate how much amount of heat is generated and how much amount of heat is dissipated, whether the artificial cooling is required or not. So that is the complete design of work and calculation of the power. Now coming to the next problem, so it is also similar problem. So they told that design a worm gear drive to transmit a power of 2 kilowatt at 1000
1000.
So
Yes, sir.
then they told that the speed ratio is 20 and the center distance is 200 mm. So here they told that design a worm gear. So we are going to design the worm gear. In the previous problem, they are not given power. We have calculated the power by using three conditions based upon the strength, based upon the AGMA VR, based upon the AGMA, we have calculated the power and we have taken which is the lesser value, that is the power. But in this problem, they have given power is equal to 2 kilowatts, capital N, and power is equal to 2 kilowatts. Power is equal to 2 kilowatts. Speed N1 is equal to 1000 RPM. I is equal to 20. A is equal to 200 mm. So in this problem, we are not going to calculate the power. So directly in the question they given the power. Only we are going to design the worm gear. So design of worm gear is nothing but we have to calculate the strength. We have to calculate the dynamic load. We have to calculate the wear load. And we have to calculate efficiency and the thermal conditions like heat generated and heat dissipated. Now as same procedure, so first in the question they have given N1 and they have given I, then by using the ratio dimension of the worm and the worm gear, that is the first step. So by taking the formula, velocity ratio I is equal to N1 by N2 is equal to Z2 by Z1 is equal to pi d2 by Z. This in the question they given N1, substitute and calculate N2. So speed of the worm gear will get 50 RPM. Next, we are going to calculate the dimension D1 and D2. So now we know the formula. Pitch diameter of the worm D1 is a to the power of 0.875 divided by 3.5 from the equation number 23.544a. Now already in the last session I told that always we have to substitute a in meters, then we will get diameter in meter, then we are going to convert into mm. So a they given in the question 200 mm. So convert into meter, we will get 0.2 meters. Substitute, then we will get diameter is equal to 69.876 mm, that approximately equal to 70 mm. Now we have calculated D1. Next we have to calculate D2 by using another formula. Center distance A is equal to D1 plus D2 by 2. A you know 200 is equal to D1, just now you have calculated 70 plus D2 divided by 2. You can calculate D2. Now whatever the D1 and D2 you have calculated, it is the approximate diameter based on the first estimation or first formula. Again we have to calculate again D1 and D2. For that we are taking another formula. D1 is equal to or approximately equal to 3 times of PC. D1 is equal to 70, we know that. That is equal to 3 times of PC is nothing but circular pitch pi into m. So we have calculated module, that is nothing but actual module we got, that is equal to 7.42 mm, that is equal to 8 mm. Now we are going to take another relation. I is equal to pi d2 divided by pz. That is nothing but velocity ratio I is equal to pi d2 divided by pz. So substitute pi d2 divided by pz is equal to pi into mx into z1. Pi get cancelled. Therefore d2 divided by m into z1. So again cross multiply. Here we are going to calculate the D2. So if you cross multiply, we'll get D2 is equal to I into M into Z1. Substitute I, substitute M. We know I is equal to 20 and we got M is equal to 8 into Z1, that is equal to 160 into Z1. Now we are going to calculate actual values of D1 and D2. Now for that, we are going to write the tabular column Z1, D2 in mm. So 1, 2, 3 or 4, 4, 5. So that is nothing but number of threads on the worm. 1 thread, 2 threads, 3 threads, 4 threads or 5 threads. Now first I will substitute Z1 is equal to 1 in the above equation. We are having equation D2 is equal to 160 into Z1. Substitute Z1 is equal to 1, then we will get D2 is equal to 160. Substitute Z2 is equal to 2, we will get D2 is equal to 320. Substitute Z1 is equal to 3, we will get D2 is equal to 480. Next, substitute Z1 is equal to 5, we will get D2 is equal to 640. Now we are having 4 values. D2 is equal to 160, 320, 480 and 640. Now we have to see previously in first estimation how much the value of D2 we got. See here, now we got in previous first estimation D2 is equal to 330 mm. Now go to the table. Now check which is the nearer value for 320 in this table. Anyone?
Sir, 2.
160.
Nearer
Z1
value of
equals to
330.
2,
320.
Z1 is equal to
320, right?
320.
320.
Yes, sir.
Therefore, D2 is equal to 320 mm. And sure.
Mm.
So therefore, since here they told that since 320 is closest to the 330, therefore taking the pitch circle diameter of the worm gear, D2 is equal to 320 mm. Now for this 320, how much Z1?
Z1 2.
Z1 how much is there? 2, right?
2, sir.
Therefore, Z1 is equal to 2. That is nothing but number of stars on worm, Z1 is equal to 2. Now we got D2 and Z1. Now we can calculate D1 by taking the formula A is equal to D1 plus D2 by 2. Cross multiply. Therefore, D1 is equal to 2 times of A minus D2. Therefore, D1 is equal to 80. Now, this is the exact value. D2 is equal to 320 and D1 is equal to 80 mm. Then in the remaining procedure, we have to substitute D2 as 320 and D1 as 80. Now, again, now Z1 is equal to 2. Now we have to calculate Z2. Z2 is equal to I into Z1. So then we will get Z2 is equal to 40. Now we got dimensions. We got number of threads on the pinion, number of teeth on the gear. Now we have to calculate lead angle. That is nothing but gamma. We know the formula. Gamma is equal to tan inverse of M into Z1 divided by D1. Substitute M, substitute Z1, D1, then we'll get the gamma. Next, in this problem, they're not given the pressure angle. So we are going to assume pressure angle alpha. If not given, always we are going to assume pressure angle alpha is equal to 20 degree full depth. Next, normal module Mn is equal to M into cos gamma. We will get normal module is equal to 7.8446 mm. So this is the first step, finding of N1, N2, D1, D2, Z1, Z2, gamma, module, axial module and normal module. This is the first step. Any doubt in this step? If you made any mistake in calculation of this, remaining procedure you will get wrong answer.
Sir, ಅಲ್ಲಿ PZ is equals to hello. ಸ್ವಲ್ಪ ಮೇಲಕ್ಕೆ ಹೋಗಿ ಸರ್. ಇಲ್ಲಿ ಸರ್ I is equals to PD2 by PZ ಅಂತ ಐತಲ್ಲ ಸರ್. PZ ಗೆ PZ is equals to pi m into Z1 ಏನಕ್ಕೆ ಸರ್?
That is the formula. PZ
ಗ ಮತ್ತೆ PC ಗೆ pi m ಅಷ್ಟೇ ಅಲ್ಲ ಸರ್? Circular.
PZ is different.
PC.
PC is different. See, I will show here. In the formulas, I will show. Here, This is nothing but circular pitch, but it's pi d2 by z2.
Yes, sir.
See, pz is nothing but lead. Pz is equal to px into z1. Px is equal to pi into
PC.
mx into z1. Understood?
Yes, sir.
PC is difference, Pz is difference. Pz is nothing but lead. ಅರ್ಥ ಆಯ್ತೇನಾ?
ಹಲೋ ಸರ್,
ಹಾ,
ನಾನು ಲಾಗೌಟ್ ಆಗ್ಬಿಟ್ಟಿದ್ದೆ ಸರ್.
here Pz is nothing but lead.
Yes, sir.
Pz is equal to Px into Z1.
Okay,
Px is
sir.
nothing but pi into mx.
ಸರಿ ಸರ್,
Px ಅಂದ್ರೆ actual pitch ಅಂತ. Understood? So now we have calculated all the dimension. Then remaining is same procedure. So any doubt up to your calculation of dimensions?
No, sir.
So next step is dimensions of the worm. Then you have to go to the table number 23.85. From that table number 23.85, from that table number you have to calculate all the dimensions for worm and for the worm wheel. Both for worm and the worm wheel, we are going to calculate the dimension from the table number 23.85. Now in this table, you will get the value for the face width. Face width B is equal to, will get 66.1 mm. Understood?
Yes, sir.
Next step is check for the strength. Now we know that Levy's equation Ft2 is equal to sigma naught to B capital Y Mn into Cv. Now here sigma naught 2 is unknown, that is nothing but the allowable static stress of the worm wheel. So in the question they not given the sigma naught 2 and they not told the worm wheel is made up of which material. So if they not told, so we are going to assume the worm material. So therefore assume hardened steel worm and phosphor bronze worm wheel. So if they not given the material for the worm and the worm wheel, we are going to assume. So always assume hardened steel worm and the phosphor bronze worm wheel. Now for this we are going to note down the value of sigma naught 2 from the table 23.96. From table we will get sigma naught 2 is equal to 55 Newton per mm square. And sure, in data and book it is 103.5. It is a printing mistake. So you have to take, instead of 103, you have to take 55 Newton per mm square. Now sigma naught 2 is over. B in the previous step you have calculated, you got 60, and now we have to calculate capital Y. Capital Y is equal to capital Y. We have to calculate. For that, before calculating capital Y is equal to pi into small y2. So first we have to calculate small y2. Since we are assume alpha is equal to 20 degree, for that we are taking y2 and we are calculating small y2. Then we are going to calculate capital Y is equal to pi into small y2. Now capital Y is over. Mn already in previous step you have calculated, and only unknown is, that is nothing but Cv. So to calculate Cv, the formula is 6 divided by 6 plus Vm. So again here Vm is unknown. So Vm is equal to pi d2 n2 divided by 60. Calculate Vm. Substitute here. Calculate Cv. So we got Cv is equal to 0.8775 and Vm is equal to 0.838. Now substitute all the things. So therefore Ft2 is equal to, so Ft2 is equal to sigma naught to 55, B is equal to 60, capital Y is equal to 0.1442, Mn is equal to 7.8446, Cv is equal to 0.8775. So we will get Ft2 is equal to 9363.5 newtons. So this is the permissible transmitted load given by the Lewis equation. Again transmitted load Again, another formula we are having FT2 is equal to 9550 into 1000 into capital N divided by N2 into R2. So now we know power is nothing but in the question they have given to N2 is 50, R2 is equal to D2 by 2. So again, we are calculating the transmitted load FT2. So now we have calculated FT. Now we are going to calculate the dynamic load. Dynamic load FT is equal to FT divided by CV. So FT is nothing but transmitted load 2387.5 divided by CV. The previous step we have calculated. Then we will get the dynamic load. So next is wear load. Allowable wear load FW is equal to D2 B into K. D2 we have calculated, B we have calculated, only unknown is K. So now we are going to calculate K based upon the material and based upon the gamma value. Now from the table 23.100 for the material, the worm wheel is made up of, and based upon the gamma value you got. So by using gamma 11.31 and by considering the iron steel worm and phosphor bronze worm wheel, we are going to calculate take value of K load stress factor. K is equal to 0.69 MPa. Substitute and calculate wear load FW. We will get this problem 13248 Newton. So this is the way. This way we are going to calculate tangential load FT2 based on the base, based upon the strength base, and we are going to calculate dynamic load, and we are going to calculate the wear load. So this is the second step, checking for the gear strength. Any doubt in this second step? Any doubt here?
No, sir.
No, sir.
So again, we'll go to the next step, that is calculation of efficiency. So already I told that here there are two formulas to calculate efficiency. One is based upon worm as the driver, and another formula based upon worm gear as the driver. So again in this question, they are not given which is the driver and which is the driver. So we are considering worm as the driver. So we are considering worm as the driver. So we are taking the formula from the equation number 23.604 H. So this is the formula to calculate the efficiency. Here in this formula, so already gamma you have calculated, alpha m you know, only unknown is mu. Mu is nothing but coefficient of friction. So in order to calculate mu, first we have to calculate rubbing velocity VR. So based upon the VR value, we are going to calculate the mu. The formula to calculate rubbing velocity VR is equal to pi d1 n1 divided by 60,000 into cos gamma. So you can ask question here, sir, why only d1 and n1? Why not d2 and n2? Why means here we are considered worm as the driver. So we are considering the worm as driver, therefore d1 and n1. And sure. So we'll get rubbing velocity VR is equal to 4.272 meter per second. Now, whatever the rubbing velocity we will get, it is greater than 2.75 and less than 20 meter per second. So based upon this, we will get the formula to calculate mu. So mu is equal to 0.025 plus VR divided by 305 from the equation number 23.570C. Now substitute VR and calculate mu. Once you get mu, substitute everything in the efficiency formula and calculate efficiency. So finally we will get efficiency is equal to 82.12%. So after calculating efficiency, next is heat generated. We are going to calculate. So the formula to calculate heat generated Hg is equal to mu Fn VR divided by 1000 from the equation number 23.603a. In this equation, only unknown is Fn. Why means already mu we have calculated, VR we have calculated, only unknown is Fn. So we are going to calculate Fn is equal to normal force. The formula is Ft2 divided by cos gamma into cos alpha. Here, when you are calculating Fn, we are going to substitute Ft2. That is nothing but Levy's equation. Whatever the formula you are having, the strength by using Levy's equation, That value you have to substitute and we are going to calculate Fn. Once you get the value of Fn, substitute in the Hg formula and calculate Hg. So we will get Hg is equal to 1.693 kilowatt. That is heat generated in the worm. Next, we are going to calculate heat dissipated. Heat dissipated HD is equal to HCR. It's listen here. Within 10 minutes, after 10 minutes, the session will be closed. Once the session will close, click on the same link. Again, you will get the same session. Continuation of the next session.
Okay, sir.
ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
ಸೇಮ್ ಲಿಂಕ್ ಮೇಲೆ ಕ್ಲಿಕ್ ಮಾಡಿ ಕಂಟಿನ್ಯೂ ಆಗುತ್ತೆ ಆಮೇಲೆ. ನೆಕ್ಸ್ಟ್, heat dissipated HD is equal to HCR into A Tg minus Ta divided by 1000. Here A is equal to radiating area of housing. The formula is 14.4 A to the power of 1.7. Substitute A and calculate area. Next, Tg. So they're not given Tg. So we are assuming Tg is equal to 65 degrees Celsius, that is temperature of air, and converting into kelvins, we'll get 338 degree kelvins. Again, Ta is equal to ambient temperature. Again, they are not given ambient temperature. We are assuming that is equal to 25 degrees Celsius. Convert into Kelvin, then we will get 298 degree Kelvin. Next, another unknown is, that is nothing but HCR. HCR is equal to, so from the figure, from figure number 23.89, based upon the radiating housing, the value of radiating housing, we are going to note down the coefficient of heat transfer HCR from the figure number 23.89 by using area of housing. So we will get HCR is equal to 320. Now substitute HCR, area, Tg, Ta and calculate the heat dissipated HD. We will get heat dissipated is equal to 11.95 kilowatt. Now you see, we got heat generated is equal to 1.69. We got heat generated is equal to 1.693 kilowatt and heat dissipated is equal to 11.95 kilowatt. Now you tell whether artificial cooling is required or not.
No, sir,
No,
not
sir.
required.
So we don't require any artificial cooling to cool the system. Why? Means heat dissipated is more compared to the heat generated. So at the end you have to write, since heat generated is less than heat dissipated, hence artificial arrangement is not necessary. Understood? So up to here we have to solve the problem, that is complete design of the gear. So it is similar to the previous problem. In previous problem they are not given power, you have calculated power. In this problem they have given power, no need of calculating the power. That is the difference for previous and this problem. And in the previous problem they given the material for the worm and the worm gear. Here they are not given, we are going to assume. Understood?
Yes, sir.
Any doubt in this problem? Draw.
No, sir.
Then we will move to the next problem. So next problem, here they told that, see, the following data refers to the worm and the worm gear drive. Center distance 200 mm, pitch circle diameter of the worm 80. They have given A, they have given D1, number of start 4, Z1, actual module M is equal to 8 mm, transmission ratio I is equal to 20. The worm gear is made up of phosphor bronze with an allowable bending stress of 55 MPa. That is nothing but sigma naught A naught. Sigma naught 1 or sigma naught 2?
Sigma naught 1.
Here the worm gear is made up of
Sigma naught
phosphor
2, sir.
bronze with an allowable bending stress of 55 MPa.
Sigma naught 2.
Always I told that the gear is represented by 2, 2, 2, 2, right? So it is nothing but sigma naught 2. Understood? Next, the worm is made up of hardened and ground steel, and tooth form is 20-degree full depth. So these are the data, and we are going to calculate number of teeth on the worm gear, lead angle, and the phase width, and they given power is equal to 15 kilowatt and speed is equal to 1750 rpm. Based upon the, then they told that rpm of the worm based upon the beam strength of the worm gear. So coming to the given data, they have given A, they have given center distance, pitch diameter of the worm D1 they have given, number of starts Z1 they given, module they given, transmission ratio, sigma naught 2, alpha, power, N1. So we have to calculate Z2, we are going to calculate gamma, and we are going to calculate phase width P. So by same procedure, first we will calculate Z2 by taking the ratio I is equal to N1 by N2 is equal to Z2 by Z1 is equal to pi D2 by Pz. So take the relation I is equal to Z2 by Z1, calculate Z2. Now Z2 is over. Next we'll calculate lead angle. We know the formula. Lead angle gamma is equal to tan inverse of M into Z1 by D1. Substitute M, substitute Z1, substitute given. So M they given in the question, Z1 they given, D1 they given. So then we are going to calculate the lead angle. So lead angle is 21.8. Next unknown is nothing but phase width B. So now to calculate phase width, we are going to take the formula transmitted load FT2 is equal to 9550 into 1000 into N divided by N2 into R2. Here power they given in the question, R2 we have to calculate and N2 we are going to calculate. So now we can calculate N2 by using the relation I is equal to N1 by N2. So N2 we will got N2 is equal to 87.5 rpm. Next, to calculate R2 we require D2. So to calculate D2, so we are using the relation center distance A is equal to D1 plus D2 by 2. Calculate D2. So we will get D2 is equal to 320. Once you get D2, calculate R2, substitute in the formula, then we will get FT2 is equal to 10232.143 newtons. So this is the transmitted load we will get. Now we are going to take Lewis equation. Again we are having Lewis equation formula, FT2 is equal to sigma naught to B capital Y Mn into Cv. Here you can see the notation of B. So here FT2 already you have calculated in the previous step. Sigma naught 2 they given in the question. We are going to calculate B. So to calculate B, now we have to calculate capital Y, Mn and Cv. So capital Y is equal to pi into small y2. Calculate y2. Then substitute, multiply by pi. Then we will get capital Y. Next, formula of Mn is equal to M into cos gamma. So we will get Mn. Gamma already you have calculated. Calculate Mn. Next, remaining unknown is Cv. So to calculate Cv, first calculate velocity Vm pi d2 n2 divided by 60,000. We'll get Vm is equal to 1.466 meter per second. Once you get Vm, calculate the velocity factor Cv, 6 divided by 6 plus Vm. Once you get Cv, substitute everything here. Substitute FT2. So previously you got here FT2 is equal to 10232.143. Substitute FT2. Sigma naught 2 in the question they have given. B unknown, keep as it is. Substitute capital Y. Substitute Mn. Substitute Cv. So here see here FT2 sigma naught 2, keep B as it is. Capital Y, Mn and Cv. So we are going to calculate the phase width. We got 69.565 mm, that is approximately equal to 70 mm. So in this way, we are going to calculate the unknowns. This is the 8 to 10 marks problem, calculation of number of teeth, lead angle and phase width. Any doubt in this problem?
No, sir.